Hi there, geometry students. We're continuing with our segment proof, so we're on the third one at this point. We're given BC equal to XY, and then we're given AC, which is the whole entire line, equal to XZ, and we want to show that AB and YZ are equal. And so we have 5 steps here. I think you might have more than 5 lines on your paper, so you maybe want to go 1, 2, 3, 4, 5. I've already erased mine. So our process is to take our givens and write them in the number 1. Write them down first. So I'm writing down my givens, and my reason is given. And then I take my proof and I write it at the very bottom because my goal is to show AB equals YZ. And so remember that we need to introduce those pieces in our proof then, because right now when I look at my givens here, I don't see any AB and I don't see any YZ. So again, in my introduction here in number 2, so I'm going to introduce my parts that I need. I'm going to introduce AB by using my segment addition postulate. So I have my AC equals AB plus BC. And then I need to introduce my YZ, which is in this one. So I'm going to go XZ equals XY plus YC. And again, remember that I put those together on one line. And that was my segment addition postulate. All right, so now when I'm looking down at number 5, I'm saying to myself, okay, I need AB over here on the left, and I'm going to need to have YZ over here on the right. Here's YZ, and there's AB. Up here, I said AC equals ZX. So here's AC. So all of this can take AC's spot. AB plus BC. So I'm doing a substitution right now. Instead of AC on the left, I'm going to put AB plus BC. Same thing, ZX is right here. ZX is the same thing as the XY plus the YZ. And that I have just done a substitution. Okay, so now I'm looking at 5 and I'm saying, hey, I got AB, that's great. I've got YZ on the right, that's great. It would be really nice if these two looked the same, because then I could subtract them off. And I can subtract them. I can get them to look alike, because up here BC and YZ are the same. So I'm going to do a substitution. AB plus YZ is the same thing as BC, so I'm going to put YX. I don't know, I think I said Z. So I'm putting YX there. Oh, and that makes me happy because I have XY there plus YZ. Now, do you guys see here that those are really the same line segment? Yeah, YX is the same thing as XY. What I just did here is a substitution. BC is being taken out, YX is going in its place. All right, now look from 4 to 5. What happens here? Here's AB, AB's down there. Here's YZ and YZ. Somehow the XY's disappear. What I'm doing there is I'm subtracting them off. So number 5's reason is the subtraction property. If you write subtraction, that would be okay as well. All right, let's take a look at our last proof. We're given XZ, so we're given that whole entire line, and XT, the whole entire bottom line, and we're given 2 midpoints. Y is the midpoint of XZ, and W is the midpoint of XT. And then our goal is to prove that the little pieces, XY and WT, are equal. And so we've got 7 steps. So 1, 2, 3, 4, 5, 6, 7. And in the number 1 spot, you're going to write your givens. And, oops, looks like I got mine kind of high up there. Given. Okay. Then go down and write your proof at the very, very bottom, xy equals wt. All right, now, when you're given something, you need to use it, people. So when I'm looking here, I am given xz and xt, so I need to use those. I can use those to introduce my xy and my wt. So once again, I'm going to use my segment addition postulate to do some introductions. xz equals xz equals xy plus yz. I'm going to go over and I'm going to use my xt, which I was also given, xt equals xw plus wt, and that is going to be my segment addition postulate. Now, this is actually, I got a little bit of a mix-up here. Here's my number 1. This is my number 2. I have too many lines. Here's what I have, people. I'm going to move this up. You probably have it in the right spot to begin with. I'll white this out so we don't get confused. All right. Now, at this point, you might be saying, I'm going to put these together here because I have xz on the left, so I'm going to take all of this. It's the same thing as xz, and I'm going to write it right there. And you might be saying, hey, here's xt. I'm going to take all of that stuff, and I'm going to write it right there. I'm going to do a substitution. Okay, so I'm going to take my xy equals my yz, and I'm going to take my xw plus my wt. And at this point, oh, this is a plus sign. At this point, I'm looking down at the end and I'm saying, good, I got xy on the left. That makes me happy. xy, xy. I got wt, I got wt. So I'm thinking the same thing. Get these two over here to look alike and subtract them off. All right, but it looks like I can't do any kind of substitution because I have nothing else above that's equal. Now, remember when you're given something, you need to use it. One thing that we have not used yet, people, is right here. We have not used these midpoints. I need to use those. I was given those. So what does it mean for y to be the midpoint of x, z? What does that mean? Those two pieces are going to be equal. So I'm going to write that down. I'm going to write xy equals yz. Now I have two midpoints, so I'm going to write them both on the same line. W is the midpoint of xt. So W is the midpoint. So I'm also going to have xw equals wt, and that's definition of midpoint. Okay, now I'm going back to number 3. And remember, I was really happy here. I got xy, I got xy. I got wt, I got wt. These are going to have to go away. They have to disappear somehow. And now am I looking? I see my yz is the same thing as xy. So I'm going to put xy right here. So in my next line, I'm still going to have my xy. Plus, this yz is coming out, and this xy is going to take its place. This xw I want gone. Well, xw is the same thing as wt, so I'm going to write wt in XW spot. I just did a substitution. Now at this point you may be saying, well, they don't look alike. I can't subtract them out. I thought I was going to subtract them out. Yeah, they don't look alike. These do though. How many XYs do you have on this side? You have 2 of them. So I'm not doing a bunch of the same types here, guys. I'm trying to do different kinds of proofs for you. 2 XYs. How many WTs do you have on the other side? 2 WTs. What did I just do here? I added those together, so this would be the addition property. So if you write add down, that's fine. If you write addition property, that's good for me too. So now look from 6 to 7. How do those 2's disappear? What do? You would divide. That would be the division property. If you write divide, that would be fine with me. Division would be great too. So we have done a number of different proofs here, people. And so if you were confused by those, don't hesitate to watch these videos again. And we'll talk about them in class, and we'll try some on our own. You guys have a great night, and I'll see you tomorrow in class.